Class 11 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 3 Coordinate Geometry. Topic Conic Section. Exercise Miscellaneous. Examples on Chapter 11. Question 1. If a parabolic reflector is 20 cm in diameter and 5 meter deep, find the focus. If a parabolic reflector is 20 cm in diameter and 5 cm deep, find the focus. Let the origin of the coordinate plane be taken at the vertex of the parabolic reflector in such a way that the axis of the reflector is along the positive x-axis. This is the origin of the coordinate axis, which is taken as vertex of the parabolic reflector. The axis of the reflector is along the positive direction of x-axis as in this diagram. This can be diagrammatically represented as in the figure. The equation of the parabola is of the form y square equal to 4ax. Since the parabola passes through the point A, whose from this to this is 5, which is f, and from this to this is 5. This is also 5. Therefore, the diameter is 10. Since the parabola passes through the point A, whose coordinates are 5, 10. Therefore, the coordinates of this point will satisfy the parabolic equation. That is 10 square equal to 4 into A into x is 5. We get A equal to 5. Therefore, the focus of the parabola for this parabola is 5, 0, which is the midpoint of the diameter. Diameter AB midpoint oigani. Hence, the focus of the reflector is at the midpoint of the diameter. Hence, the focus of the reflector is at the midpoint of the diameter disc. Question number 2. An arch is in the form of a parabola with its axis vertical. The arch is 10 meter high and 5 meter wide at the base. How wide is it 2 meter from the vertex of the parabola? The origin of the coordinate plane is taken at the vertex of the arch in such a way that its vertical axis is along the positive y-axis. This can be diagrammatically represented as in the figure. This is the arch whose vertex is at the origin, whose axis is also along the positive direction to y-axis. The equation of the parabola is of the form x square equal to 4ay. It can be clearly seen that the parabola passes the point 5. This is 5, therefore it must be pi by 2, and whose coordinates will be pi by 2, 10. Therefore, the coordinates of this point will satisfy the above parabolic equation. That is from which we get a equal to pi by 32. Therefore, the arch is in the form of parabola x square equal to 4 into a, whose value is pi by 32 times y. That is pi by 8y. When y is 2 x squared, above equation becomes x square equal to pi by 8 into 2. That is x equal to root over pi by 2. Therefore, AB is what? AB is 2 root 5 by 2. That is root 5. Whose value is approximately equal to 2.23. AB is 2.23 meter. Thus, when the arch is 2 meter from the vertex of the parabola, its height is 2.23 meter approximately. This length is approximately 2.23 meter. Question number 3. The cable of a uniformly loaded suspension bridge hangs in the form of a parabola. The roadway, which is horizontal 10 and 100 meter long, is supported by vertical wires attached to the cable. The longest wire being 30 meter and the shortest being 6 meter. Find the length of a supporting wire attached to the roadway 18 meter from the middle. The vertex is at the lowest point of the cable. The vertex is at the lowest point of the cable. As in this picture, this is the cable. The origin of the coordinate plane is taken as the vertex of the parabola. This parabola, whose vertex is at the origin of the coordinate system, while its vertical axis is taken along the positive y-axis. This parabolic cavern is whose axis is vertical along the positive direction to y-axis. This can be diagrammatically represented as in the figure. Here AB, here AB, here AB, and OC are the longest and the shortest wires attached to the cavern. This is cavern, this is the shortest cavern, the longest cavern, this is the shortest cavern. DF is the supporting wire attached to the roadway 18 meter from the midden. This is the midden. This is 18 meter. 18 meter from O to is 18 meter. This is the cavern. Length of the cavern attached to 18 meter from the midden of the cavern. Here AB is 30 meter. AB is 30 meter. OC is 6 meter. BC is what? BC is 100 meter. Whose half is 50 meter. This is 100 meter. This is 100 meter. The equation of the parabola is of the form x squared equal to 4ay. The coordinates of the point A are 50, 30 minus 6, that is 50, 24. Since a 50, 24 is a point on the parabola, the coordinates of this point will satisfy the parabolic equation, that is 50 squared equal to 4a into 24, that gives a equal to 625 by 24. Therefore, the equation of the parabola is x squared equal to 4 into a, whose value is 625 by 24 into y. Cancelling, we get 6x squared equal to 625y. The x coordinates of point D is 18. The x coordinate of the point D is 18. Hence, at x equal to 18, we get this, from which we have y equal to 3.11. Therefore, DE is 3.11. Therefore, DF is already EF is equal to OC, which is equal to 6 meter. Now D is found out, whose value is 3.11. Adding these two quantities, we get 9.11. Thus, the length of the supporting wire attached to the roadway 18 meter from the midden is 9.11 meter approximately. Roadway dagi 18 meter chatlaga laiba wire adu attached to the wire gi asang bodu 9.11 meter ni chawrak. Question number 4. An arch is in the form of a semi-ellipse. It is 8 meter wide and 2 meter high at the center. Find the height of the arch at a point 1.5 meter from one end. Since the height and the width of the arch from the center is 2 meter and 8 meter respectively, as in this picture, it is clear that the length of the measured axis is 8 meter, while the length of semi-minor axis is 2 meter. This is 2 meter, this is 8 meter. The origin of the coordinate plane is taken as the center of the ellipse, while the measured axis is taken along the x-axis. Hence, the semi-ellipse can be diagrammatically represented as in this figure. The equation of the semi-ellipse will be of the form x squared by a squared plus y squared by b squared equal to 1, where y should be upward portion. Any point, the y coordinate of any point on upward of the x-axis is always positive, where a is the semi-measured axis. Accordingly, twice a equal to I, twice a, this is I, therefore this should be equal to twice a, gives a equal to 4, b equal to 2. B is already, it is found to be 2. Continue. The equation of the semi-ellipse is x squared by 16 plus y squared by 4 equal to 1. Y should be greater than or equal to 0, as in this picture. Let A be a point on the measured axis such that AB is 1.5. Draw AC perpendicular to OB. Draw AC perpendicular to OB. Also OA is 4 minus 1.5, that is 2.5 meter. Therefore, x coordinate of C is 2.5. Put x equal to 2.5 in the above equation. We get 2.5 squared by 16 plus y squared by 4 equal to 1. Solving, we get this, from which we get y equal to 1.56 approximately. Therefore, AC is 1.56. Thus, the height of the arch at a point 1.5 meter from one end is 1.56 meter. 5. A rod of length 12 cm moves with its ends always touching the coordinate axis. Determine the equation of the locus of a point P on the rod, which is 3 cm from the end in contact with the rod. A rod of length 12 cm moves with its ends always touching the coordinate axis. Determine the equation of the locus of a point on the rod, which is 3 meters from the end in contact with the rod. Let AB be the rod making an angle theta with OX. Let P and P of XY be the point on it such that AP is equal to 3 cm. AB is the rod of 12 cm, touches the coordinate axis. And P is a point X whose coordinates are XY at a distance of 3 meters from the end A, and the angle made by BA with angle BAO be taken as theta. Then PB draw P. Then PB is what? AB minus AP. That is 12 minus 3. That is 9 cm. From P draw PQ perpendicular to OY and PR perpendicular to OX. In triangle PBQ, cos theta is PQ by PB, whose value is x by 9. In triangle PRA, sin theta is PR by PA is equal to y by 3. But sin square theta plus cos square theta is 1. Putting their respective values from above, we get this, which is an equation of an ellipse. Thus, the equation of the locus of the point P on the rod is x squared by IT1 plus y squared by 9 equal to 1. Remember, this ellipse equation represents an ellipse. 6. Find the area of the triangle formed by the lines joining the vertex of the parabola x squared equal to 12y to the ends of its lattice rectangle. Find the area of the triangle formed by the lines joining the vertex of the parabola x squared equal to 12y to the ends of its lattice rectangle. The given parabola is x squared equal to 12y, which can be written as 4 into 3 into y, as in this picture. On comparing this equation with x squared equal to 4ay, we get a equal to 3. Therefore, the coordinates of focus are s of 0, 3. Let AB be the lattice rectum of the given parabola. The given parabola can be roughly drawn as in this figure. As in the figure, let y equal to 3. Let y equal to 3. At y equal to 3, x squared equal to 12 into 3 is 36. Gives x equal to plus minus 6. Therefore, A, whose coordinates are minus 6, 3, and B, whose coordinates are 6, 3. Now we have known the coordinates of A, B with S, A, B with O. Therefore, area of triangle OAB is equal to half 0 times of 3 minus 3 plus minus 6 times of 3 minus 0 plus 6 times of 0 minus 3. Solving, we get 18 square units. Thus, the area of the triangle is 18 square units. 7. A man running a race course notes that the sum of the distances from the two flag posts from him is always 10 meters. Find the distance between the flag posts is 8 meters. Find the equation of the post traced by the man. A man running a race course notes that the sum of the distances from the two flag posts from him is always 10 meters. And the distance between the flag posts is 8 meters. Find the equation of the post traced by the man. Traced or traveled by the man. Let A and B be the positions of the two flag posts and P be the position of the man. Accordingly, we have PA equal to PA plus PB equal to 10. We know that if a point moves in a plane in such a way that the sum of its distances from two fixed points is constant, then the path is an ellipse, and this constant value is equal to the length of the measured axis. Therefore, the path described by the main is an ellipse. Here, the length of the measured axis is 10 meters. Find points A and B are the foci. Continue. Taking the origin of the coordinate plane as the center of the ellipse, find taking the measured axis along the x-axis. The ellipse can be diagrammatically represented as measured axis along x-axis, minor axis along y-axis. The equation of the ellipse would be of the form x squared by a squared plus y squared by b squared equal to 1, where is the semi-measured axis. Accordingly, twice a is equal to 10 gives a equal to 5. Distance between the foci is twice c, which is given as I, from which we get c equal to 4. On using the relation c equal to square root of a square minus b square, we obtain 4, c is 4 equal to a square is 25, b square, b equal to 3. Thus, the equation of the path traced out by the main is x squared by 25 plus y squared by 9 equal to 1. Question number 8. An equilateral triangle is inscribed in the parabola y square equal to 4ax, whose one vertex is at the vertex of the parabola. Find the length of the side of the triangle. Let OAB be the equilateral triangle inscribed in the parabola y square equal to 4ax, as in this picture. This is an equilateral triangle inscribed in this parabola, whose one vertex is at the origin. Let AB intersect the x-axis at the point C. Let OC distance be taken as k. We obtain y squared equal to 4ak, from which y equal to plus minus 2 square root of ak. Therefore, A whose coordinates are this and B whose coordinates are this. Therefore, AB is 4 times the square root of ak. Since OAB is an equilateral triangle, OA square equal to AB square, OA square equal to AB square. Giving their values, we get this. Simplify, we get k equal to 12a. Therefore, AB is 4 root over ak, 4 times of 12a square, that is 8 root 3a. Which is thus the side of the equilateral triangle inscribed in the parabola y square equal to 4ax is 8 root 3a. Thank you for watching video.